Welcome back to the Clean Classics EV conversion checklist. This is part 4 and we're going to be talking about battery capacity, range and charging. So first thing to explain, I suppose, is it can be a bit confusing when you're first getting into electric cars. The quantity you're talking about in terms of the capacity of a battery is kilowatt hours, and that quite simply is the number of kilowatts that you would run for an hour for it to drain completely. So if you run a 40 kilowatt hour pack, if you run that at 40 kilowatts continuously, it'll work for an hour, and you've basically got the proportional mass around that to work out how that's going to work. As for the number of kilowatt hours you might want to put into your EV conversion, like how many kilowatt hours do you want to have in your new EV, it very much depends on the car itself as to how far that's going to go, and also how you're going to use it in terms of how far do you want or need it to go. I always tell people who, if they want to use a car regularly that's an EV, I always say absolute maximum, your daily number of miles on the regularly used wants to be absolute maximum 50% of your charge cycle. Really wants to be considerably less than that for your charge, for your sort of battery longevity effectively. So that's one part of the picture to be thinking about. But on the classic car end of the scale, it's less likely going to be your everyday car and more just a more for fun car. Actually, what I think is more important is matching the weight of your battery system to the car itself and balancing that out with the amount of range that then gives you. Trying to use modern vehicles as a benchmark in terms of how much range you'll get out of a classic conversion is generally not a very effective way of doing it. Modern cars are very efficient and their aerodynamics are really well optimized. Even SUV type ones, they've done a very good job of all of the efficiency and getting it so you can get as far as possible on a charge. So that's not a very good way of gauging it. The best way to know how far a classic vehicle conversion is actually going to go on a given charge is just testing. You can have a reasonably good stab in terms of ballpark range, but really there's nothing like real world testing to find out exactly how your combination of weight and battery charge and general vehicle packaging is gonna sort of work out into real world range. So just getting out and testing is gonna give you the best answer on there. That means any companies specializing in a vehicle conversion, they're going to have much more information on how their conversion works in the real world setting and what kind of environments are going to give the best range for their vehicle and what's going to not perform quite so well. Then there's charging an EV, and it gets people chatting a lot, that's for sure. There's two main kinds of charging and charge speeds. There's fast charging and then there's rapid charging. Fast charging is AC. AC is voltage and current you'll find in your house. Alternating current is what it stands for. This is effectively the slower of the two options, but the more commonly used. If you've got a home charger, this will be AC fast charger. The most common speed there is 7 kilowatt. So that AC fast charging can, if there's a 3-phase connection to a site, it can go up to 22 kilowatts, but quite often I don't think there are actually that many even OEM EVs that go up to 22. I think Tesla's 11 kilowatt AC charging max. So there's only a few that you can actually do 22 kilowatt charging. Really, the 7 kilowatt is the kind of benchmark and what the kind of the norm for charging at home. Then there's rapid charging, and this is what you'd find at a service station. Tesla superchargers, it's that kind of real high power charge systems. This actually works, it's a DC system, so it links directly to your battery and provides the correct DC voltage just to chuck it in there as fast as it can. The power's here in comparison to a maximum of 22 kilowatts for the AC charging. The DC charging is between 50 and 300 kilowatts, and it's this technology that allows that charging up in half an hour while you go and grab a coffee. This is a really important thing to think about because your vehicle, like we've spoken about in some previous videos, it needs to be of that OEM level voltage. If you've got a lower voltage system, like a system that runs on Hyper 9, for example, then your battery is never going to be compatible with this rapid charging. So if you want to utilize that infrastructure and want to be able to make those slightly longer journeys with a bit of a splash and dash rapid charge, then there's a fundamental decision you need to make in your overall vehicle architecture. If it's something you're thinking about upgrading, then you need to have that higher voltage system. So in the Clean Classics Land Rover conversions, we've got a 40 kilowatt hour battery pack, and that gives up to 100 miles of range, which in terms of the sweet spot between drivability and the amount of weight added, that is, we find that 40 kilowatt hour pack is a really good balance. It's not all about having the highest range, because you can always add rapid charging to get a bit further. It's about having a package that's going to suit an old vehicle really well to make it much more usable. Thanks for watching. Come back to check out part 5 of the EV conversion checklist. And as always, like and subscribe.